What if it were possible for people to meet all of their basic human needs for food, water, shelter, energy, and sanitation from sunlight alone without relying on any grid infrastructure at all? This is the question that's been keeping me up at night, because not only do I think it's possible, I think it's highly feasible, and I want to explain why I think that and what I'm doing about it. I find it helpful to think of ecosystems as ecological circuits. Sunlight flows through an ecosystem in a similar way to the way that electricity flows through an electrical circuit. And just like the individual capacitors or transistors perform specific functions in an electrical circuit, species in an ecosystem each perform a specific set of chemical functions. And the basic pattern is plants turn sunlight into biomass, and animals then eat that biomass and other plants, and then bacteria and fungi decay all the waste back down into the nutrients that plants need to grow again. This reciprocal cycle is a complete ecological circuit, and as long as there's sunlight to power it, it can recycle the exact same organic material indefinitely. Humans are capable of applying our intelligence to design ecological systems that are tailored to meet all of our specific human needs from sunlight alone in this exact same way, in a symbiotic relationship with plants, animals, bacteria, and fungi, and also machines that we've designed. And a really great example of this is aquaponics. When you raise fish and vegetables together, the fish fertilize the plants, and the plants filter the water for the fish. This is an example of a human-designed ecological circuit, and the fish and vegetables can each be thought of as an ecological component. We're just beginning to scratch the surface of what's possible with this kind of human-directed ecological design. And in fact, there are millions of examples of technologies like this, of these ecological components that could serve specific individual functions like electronic components in complete ecological circuits. These are things like biodigesters, slow sand filters, solar panels, gasifiers, hydroponic grow beds, and composting toilets. And all of these components are being pioneered by a worldwide maker movement. And they're already widely available, cheap, and many of them are already open source. The problem is that they're all being developed individually, and like individual transistors or resistors compared to a complete working computer, none of them is as useful alone as they could be if they were part of a functioning, complete ecological circuit. But to build these kinds of ecological circuits, we need a standardized way of communicating very complex designs to one another. And if you look around, you can see that the people who are working on regenerative designs are all struggling with this same problem of how to convey these complex ecosystem maps and diagrams in a way that makes sense, and how to figure out how to put all of the individual components together in ways so that they function as part of a larger whole. So what we've been developing is an open source, easy to use, visual ecological circuit diagramming platform. My vision is to make an expandable library of all of these existing ecological components, along with all the data that we have about their real-life input and outputs, so it's easy to connect them together in a visual, virtual space, so that the computer can help us do the complex, emergent, self-referential math required to build ecosystems like, given the total solar irradiance or yearly solar irradiance of Southern Oregon, how many farm bots am I going to need in order to feed myself all year round? And if I do that, how many open source biodigesters will I need so that I can break down all of the waste biomass they produce? And how many kilowatt hours of electricity can I expect per day from the biogas that they produce? And is it cost effective to use that electricity to run LED grow lights during the winter? Software can easily do these calculations in ways that we can't. The calculations will obviously never be perfect, but they'll be close enough that ecological designers around the world can then easily and rapidly share their designs and innovations with one another, so that the assumptions of promising designs can be tested out in the real world, and we can systematically and collaboratively improve them. I'm requesting the support of the Shuttleworth Foundation so that I can build this prototype out into a stable, usable tool, so that together we can rapidly design complete, open source, ecological systems that can meet all basic human needs from solar energy the way that all other living systems do, so that we can build a human society that is photosynthetic and capable of enduring for generations to come without causing any further ecological damage and systematically healing the damage that has already been done by our reliance on fossil fuels. Thank you.